Now it is visible?
Yes, sir.
It is in full screen, no?
Yes, sir. Yes.
Okay. Thank you, Raghav. And good morning to all.
Good morning.
We are 10 minutes late because we are today's lecture is on analysis of nutrient content in various compost and calculation of nutrient requirement. This is our topic. So this lecture will be very, I expect that lecture should be very interactive and some questions, some interest or some queries should come from the participants also, because this is very important and scientific tools for characterization of organic manure, organic farming. As we are certified as advisor, so we should know the background of our organic farming and how we are calculating and we are applying different types of nutrients through different organic source to fulfill the nutrient requirement of crop under organic farming. So what is the science behind this? Because we are applying different in chemical fertilizer, we are applying 80-40-40, and this 80-40-40 NPK we are applying through different types of fertilizers. But in case of organic farming, there is a restriction because there is a limited source of plant nutrient, limited source of plant nutrients which can be permitted only in the organic farming. So we have to manage our organic farming scientifically, as we are concerned about the organic farming and we are advisor to the organic growers. So we should be very scientific for recommending the different types of organic source of nutrient to fulfill the nutrient requirement of crop in the organic systems to get optimized yield in the organic farming system, so that farmers encouraged to cultivate or to accept our technology in our organic farming. So before that, as we are an advisor, before that we should know the background and how to plant uptake nutrients. Plant uptake nutrients from soil and water solution. This is the basic, because that's why we are applying the irrigation water in the soil after applications of chemical fertilizer or organic fertilizers, irrespective of the chemical farming and organic farming. So water is very important source for making the availability of nutrients for the plant uptake. And if we are considered if we think and if you see the 90% obtained in soil water solutions. So soil water solution is very important media for supplying the nutrient source for plant uptake. So we should consider, or we should think about the soil solutions, and only the 2% plant nutrient uptake occurs directly from the soils, and as that through the contacts of the plant roots with the soil particles, the nutrient is directly absorbed from that site. So the main source is the soil water solutions. So when we are applying the different types of organic manure that not soluble in the organic soil water solution in the soil, or the water content in the soil. So there's water, anyhow we make our nutrient for the availability or for the uptake of the plants in the soil solutions. If we are applying, suppose we are applying compost. So compost is not soluble in the soil water solutions. It should be mineralized and converted to nitrate or ammoniacal form. So we are applying organic source of nutrient, but the plant cannot take as such as an organic source from the soil water from the soils. That whatever we are applying, that should be converted into the available form for the plant uptake. And in organic farming systems, the main organic package, whatever we are following in India, based on the nitrogen requirement. So we should concern about to fulfill the nitrogen requirement of the crop or plants under organic farming system. On the basis of that, we are supplemented other primary nutrients, that is phosphorus, potassium, then different types of micronutrients, and all this should be in the plant available form. Plant cannot recognize whether it is coming from the organic source or it is coming from the inorganic source. They only bother for the form of organic nutrient which is available for their plant uptake. That is, in case of nitrogen, that's ammonia or nitrate form. And it may come from the organic source, it may come from the inorganic source, but the nitrogen source should be in the soil solution, should be in the form of ammoniacal and nitrate source. So for nutrient uptake, and why the nutrient, we are very much bothered about the different the nutrient in the soil solutions. We know the criteria for the essentiality of element, why it is called as an essential nutrient in our plant nutrient uptake systems, and it has the three principles which is already defined and already well defined by the Arnold and Stout in 1939 and 1954. And that what is the criteria of the elements? The plant must be unable to complete its life cycle in absence of the mineral nutrient. That means that without this element, plant cannot survive or cannot complete its life cycle from seed to harvest. And the function of the element must not be replaced by the another mineral elements. Suppose the nitrogen is not available. This nitrogen, whatever the activity is influenced in the plant system by the nitrogen, cannot be done by the other elements. That's why the nitrogen is essential elements, and the elements must be directly involved in the plant metabolism, such as the component of an essential plant constituent or required for the distinct metabolic step like enzymatic activity. In the different types of micronutrients, they are taking important role in the enzymatic activity. Suppose whatever the activity is controlled by the, managed by the, or regulated by the zinc, that cannot be replaced by that activity or the function. It cannot be replaced by the, substituted by the iron, and that's why the zinc is a essential element. In this way, we have characterized the essentiality of nutrient in the plant systems for plant nutrient uptake. And this is the primary nutrient, that is nitrogen. Nitrogen, we know the nitrogen is the primary nutrient. But in the field, how we can diagnose that the deficiency symptoms due to the nitrogen. And this is a maize plant which is very much sensitive to the nitrogen applications, and the nitrogen is most important nutrient, and the deficiency symptoms can be recognized by the reduced growth and yellowing of lower leaves, and yellowing is called chlorosis. That is this is the chlorosis. And from these symptoms, by these symptoms, we can easily recognize that this deficiency symptoms due to the nitrogen deficiency. And this is another primary nutrient is the phosphorus, and this phosphorus deficiency can be easily recognized through these changes of color, plant leaf color of the maize plant, that is reduced growth, poor root systems, reduced flowering, and also thin stem and browning or purpling of the foliage. This is the maize plant, and this is the purpling of the leaves, and that symptoms indicate that soils have a deficiency of phosphorus. And in case of potassium, in the potassium, the reduced growth, shortened internodes, and some burn, scorches marks, brown leaves. And this is if you see these symptoms, that the margin of the plant leaf is like burning effects, and these symptoms particularly indicates that soil is a deficiency of potassium. And by this way, by recognition in the field conditions, by recognizing the symptoms of the deficiency symptoms, we can easily detect it, what types of nutrients we have to immediately apply to rectify these deficiency symptoms and for obtaining a optimum yield under organic farming systems. Because if you see the compare the chemical cultivations and organic cultivations. Chemical cultivations, there is so much options, but in case of organic, there is a limited or restricted source of nutrients by which we can rectify. That's why we are very much scientific and very much to the points for the applications of the plant nutrients under organic farming systems, because whatever nutrient we are applying as a source of nutrients, that not become easily available to the plants, and at first whatever we are applying, that should be mineralized, then it become available to the plants. And but in case of chemical fertilizer, there is no such restrictions. Whatever you are applying, these nutrients will go into the soil water solutions and dissociates and become in the plant available form. So we should know the scientific backgrounds of the different source of nutrient, organic source of manures under organic farming systems. And for we are going to apply the organic nutrient sources, but before that we have to calculate, because in different soils have a different requirements for making the availability of plant nutrient uptake, and in that case pH is the most important factors which influences the availability of plant nutrients to the in the soil water solutions. And if you see the pH range, we can categorize our soil systems in different categories, that is extremely acid to extremely alkaline. And if we see the pH is the exchangeable hydrogen ion in the soil solution present when the pH is less than 4, while the exchangeable aluminum predominant occurs at the pH 4 to 5.5, and aluminum polymer occurs in the pH range 5.5 to 7. So from this pH range, we can recognize, or we can think, or we can assume that in that range, these types of hydrogen ion or aluminum polymers is predominant in the soil solutions, and accordingly we can select that source of organic nutrients for the applications in the soils in under organic production systems. And this is the lithotropic series, where with the increase of the pH, the aluminum is a very acidic, then the calcium is towards alkaline, magnesium alkaline, potassium and ammonia is in the same range, and the extremely strongly alkaline is the sodium. This is the lithotropic series, and where we can recognize or where we can draw conclusions that these types of nutrients or elements is predominant in the soil solution. And another important parameter in the soils under organic farming systems is the organic carbon, because in one directions we are talking about the we are promoting organic farming because of to get a healthy food for our for the people. But in another sides, the organic farming also increase the carbon content in the soils through carbon sequestration, by which we can eliminate the yield effect of climate change in the soils through carbon sequestration. And this is the and also, if the organic carbon is higher, then the soil have a the soil can be called as a healthy soil, because this due to the higher amount of organic carbon, the nutrient holding capacity, water retention capacity, porosities of the soil is improved, and by which we can calculate by considering the health conditions. Suppose we are going for a doctor for our some treatment in our doctor, and before that start their treatment, they are recommending for some testings, and from the testing results they can prescribe a list of medicines for our recovery. And similarly, in the organic carbon content, organic source, how much organic carbon is present in the soils, from that point we can calculate how much nutrient is required for making that nutrient availability for the plant uptake. And this is an important factor of the percentage of organic carbon in the soils under organic farming. And the soil organic carbon and soil organic matter, two things is different. And if the organic carbon, many times we think that organic carbon and organic matter is same, but it is not. The organic matter is the organic carbon into 1.724. This factor should be multiplied with the organic carbon that indicates the organic matter content in the soils. And this organic matter consider or covers the whole organic carbon in the soils, for which we can recognize the status of the soil, soil health status under organic production systems. And this is the different range of nitrogen in the soils through which we can categorize the soil conditions as a very low, medium, moderately high, high or very high, high content of nitrogen in the soils through this results, and which ultimately influences or which ultimately helps for the prescription of nutrient recommendations under organic production systems. And this is the phosphorus. This is the range from which we can consider during the prescriptions of the phosphorus recommendations in the soils. And this is the potassiums, and this is the range of the different types of important micronutrients in the soils, through which we can easily recommend, or we can easily understand whether soil is deficient of micronutrients or not. And this we are very much concerned about the micronutrient, because the micronutrient play an important role for regulating the enzymatic activity in the plant metabolic process. And that's why if the plant metabolic process is hampered, the production systems for optimum productions or yield from a systems, it gets reduced. So the micronutrient play an important role for the biochemical reactions in the plant systems, and directly influence, which ultimately influence the yield content of the plants. And if we see the nitrogen use efficiency, phosphorus, potassium, sulfur, and micronutrient, and this is the use efficiency. If we see, the most important is the nitrogen and the phosphorus. The use efficiency is very much low because the primary nutrient is nitrogen, phosphorus, potassium. As compared to the potassium, the nitrogen, phosphorus use efficiency is very much low, and that's why we have to calculate the nutrient requirement from this by considering the use efficiency of nitrogen and phosphorus in the soils. So before recommendations of the nutrient for a particular crop in the organic farming systems, we should know at first the status of the nitrogen, the different nutrients, as well as different micronutrient and secondary nutrients. What is the present conditions of the soils before recommendations of the fertilizer in the organic production systems? And this is the different source of nutrients used under organic farming systems, and this is the different source, that is the manures, then green manures, non-edible oil cake, edible oil cake, and this is the rough and approx percentage of plant nutrients which are available in this different source of organic manure, which are frequently used or we are generally used under organic production systems. And I have already told that nitrogen is important in the organic farming systems, and on the basis of the organic nitrogen, on the basis of the requirement of nitrogen, we are calculating how much organic manure is required. So for recommendation or for prescriptions or for the calculations of the organic manures under organic production systems, we should prepare the nitrogen budgeting for organic farming. And in that cases, use of organic sources is 50 to 60% as against the 30% of fertilizer. So calculate the nitrogen credit from the green manure, cover crop, mulches, then soil having 1% of soil organic matter release up to 10 to 12 kg of nitrogen per hectare per year. And during the nitrogen budgeting, we should also consider the nitrogen fixing microorganisms present in the soil, because the nitrogen fixing microorganisms also added 10 to 15 kg of nitrogen per hectare per cropping cycles. And nitrogen available to current crop can be estimated 70% from the concentrate organic manure. That concentrate organic manure should have the CN ratio below 10:1. And we have a different source of organic manures in the organic farming systems. But in that cases, in organic manure, the CN ratio is very vital, is very important factors by which we can easily detect whether it become easily available to the plant or it is not become available. Because in rice crop residue, in wheat crop residue, the CN ratio is high, but this is also a source of organic manure. But when we are applying in the soils, that not become easily available to the plants because CN ratio is high. Whereas in case of leguminous crops, the CN ratio is low, so it become easily available to the plants as CN ratio is below or 10:1. So, but this factor is not considered in case of chemical agriculture, because we are directly applying the urea, potassium, phosphorus, then phosphate through different chemical fertilizer. But in case of organic manure, before applications of the organic manure, we should know the CN ratio of the organic manure, by which we can detect or we can recognize whether it become easily available, or how much time it will take to become available for the plant uptake. And I have already discussed the organic carbon, organic matter is play an important role. We know the soil, the water is a important natural resources and play an important role in our agriculture systems. If through organic farming, we can increase the organic carbon content in the soils. If we increase the 0.5% of 0.5% of organic matter, then we can save 80,000 liter of water. Then 1% 160,000 liter, and likewise with the increase of the organic matter content, we can reduce the water requirement in our production systems, and that is only possible through the organic farming systems. And that's why the organic farming we are encouraging, because now day to day the groundwater as well as the sweet water become scarce in our agriculture systems, and that's why we are encouraging the organic farming. Let's move a simple calculations, that how we calculate it available in our soil analysis report. We see the soil available nitrogen is 82, soil available phosphorus is 10, and soil available potassium is 106. This is the result, and you have to apply the recommended dose of fertilizer 80 40 40. So then how we calculate the fertilizer or nutrient requirement of a production system? 82 in the range of very low, and that's why we have to increase 80 plus 50% higher of the recommended dose. That means 80 plus 50% of 80 means 120. So, and in case of phosphorus, the 40 is the recommended dose, and we in the phosphorus in the range of lower level. So very in the higher level, that is the 25% more we have to apply. So 40 plus 25% of the 40, that is 10. That means the 50 kg. So the recommended fertilizer dose will be 120, 50, and 40, and that is the recommended dose for a particular crop in a cropping systems whose have the recommended dose of fertilizer 80, 40, 40. And by this way, we can calculate the recommended dose of fertilizer during our fertilizer prescriptions in the organic farming system. And likewise, this is the range. If the soil test value is high, very high, then 50% of the recommendation dose will be applied. And if the high range, then 25% less. Then moderate, that recommended, and moderately high is the recommended, and the low is the 25% more, and very low 50% more. And this rule is followed during the recommendations of the plant nutrients for in a cropping systems under organic farming. And another is the problem is the soil reclamations, and this is the calculation by which we can calculate the lime applications to our targeted pH level, and this for this you require the CEC value, the initial pH, and the base saturation, and this is our target pH 6.5, and the target base saturation is the 80%. So how much lime is required to making the soil pH 6.5 and 80, and this is the calculation by which we can calculate the lime calculations for reclamations of the soils or under organic farming systems. And this is the base saturation. Base saturation actually indicates the nutrient holding capacities of the soils, and base saturation should be in the higher range through which we can hold the plant nutrients in the soils and gradually release in the soil water solutions from where the plant can uptake gradually to meet up their requirement. And in case of, because this calculation is very much interesting, because you are all going to submit project report or project synopsis for for assignment. And if we interested to see how much the contributions of the organic source of nutrient in the soils, we through these calculations we can easily calculate the contributions of the organic source of nitrogen, organic source of manures in the soils for plant nutrient uptake. And through designing the experiments and applying this formula and calculations, then you can easily calculate the what is the contributions of the organic matter or compost for plant nutrient plant production systems. And this calculations or this equations is was given by the Ramurthy et al. 1967. That time they have already established from their long-term fertility trial. They have calculated, and they have calculated the contributions of the organic matter for the plant uptake, nutrient uptake from the soil water solutions in the soils. And we know that we are preparing the different soil health card and soil analysis report, and the through the chemical fertilizer, through the applications of the chemical fertilizer, the response of the response to the nutrient is gradually decreasing, and then the gradually because we are discouraging the applications of the organic manures, and which influences the nutrient uptake. And this is the trend from 1960 to 2010. So there is a decline trend, because we are discouraging the applications of the organic manure in the soils. That's why the response to the chemical fertilizer is gradually decreasing, and that's why we are always recommend the applications of FYM along with the chemical fertilizer. And this is the actually scientific background why we are applying, or why we are recommending the FYM, that is FYM 10 tons per hectare, 10 tons per hectare plus 80-40-40 NPK. We never recommend that only we apply 80-40-40. We recommend that 10 tons of FYM per hectare, then 80-40-40 we apply there, because to improve the soil response to the applications of the chemical fertilizer, whatever we are applying in the soils. So there is a important role or important response of the compost in the soils. This is the status of the different samples, and most of the soils, and the 63% of the soil samples, whatever we have analyzed, that 63% of the soils are low in nitrogen. Then this is the medium, in low in nitrogen 63, medium 26, and the high is the 11%. So our Indian soils are low in nitrogen content, and that's why we are very important concentrate or concerned about the nitrogen. And this is the different secondary and micronutrient deficiency percentage of the samples we are getting during the analysis of the soil samples collected from the different pockets of our country. This is the sulfur deficiencies in Indian soils gradually becoming alarming situations and challenging situations for Indian agriculture, that is sulfur deficiency. And this is the zinc deficiency. In respect of the zinc deficiency, Uttar Pradesh that have 46% deficient soils are deficient of the zinc. This zinc is very important, because this zinc regulated the different enzymatic activity plus biochemical activities in the plant systems, and which ultimately affects the yield of the crop. And the boron deficiency, then the this is the actual status of the nutrient, whatever we are applying or what is the requirement of the applying, we know this is sufficient to before recommendations of the plant nutrients for a agriculture production systems. Now the how we estimate the nitrogen content, total nitrogen content in compost, because this compost is most important source of organic under organic farming systems. One lacuna or one disadvantage with the organic farming system is that there is so much variations of the organic source of nutrients, because the substrate is different and it's vary from agroecological region to region. So then at first the nutrient content of the source should be analyzed properly. Now the nitrogen content of Modipuram is different from the nitrogen content of Tamil Nadu, and nitrogen content of Tamil Nadu is different from the Kerala, Karnataka. So before recommendations or before applications of the organic source of nutrient, we should know the actual percentage of nitrogen present, or nitrogen or different types of nutrient present in the organic source or organic manure, and from that percentage of nutrient we can easily calculate how much organic manure we have to apply in the soils for getting the optimum yield from the production system. In case of estimation of the total nitrogen in the compost, we generally in case of compost there is a two source of nitrogen, two form of nitrogen, that is in the nitrate form plus amide form, that is at present as a protein in the organic source. But in the estimations of the nitrogen, anyhow we have to convert these different forms of nitrogen in the ammoniacal form, because through distillations we can easily estimate the how much percentage of nitrogen is present in the organic manure. So the amide form, then a nitrate form, we have to convert into the ammoniacal form. And in case of compost, we digest at first we digest with the sulfuric acid and salicylic acid in presence of the potassium sulfate and copper sulfate. In potassium sulfate, the increasing the boiling point of the H2SO4 and this copper sulfate as act as a catalyst to enhance the digestions of the organic the compost samples present in the soil. And this is the chemical equations through which the salicylic acid we are applying along with the we are taking along with the sulfuric acid. The salicylic acid is converted the react with the nitrate form to convert into the nitrosalicylic acid. This nitrosalicylic acid then reduced by the thiosulfates to form the ammoniacal form ammonium sulfate. This from this ammonium sulfate, the ammonia is distilled through the Geldal methods from where we can estimate the how much nitrogen is present in the organic source of nutrients we are applying going to apply in the field. So before that we should consider or we should convert all forms of nitrogen in the ammoniacal form of nitrogen, and this ammoniacal form of nitrogen is easily distilled through the Geldal distillation procedure, and where we can estimate the how much nitrogen present in the soils. And this is the procedure protocol how we can calculate or how we can estimate the nitrogen content in the soils, and ultimately when we when the compost is completely digest, this digest samples is distilled with the 45%, 40 to 45% sodium hydroxides in the distillation assembly, and this whatever the ammonia is distilled, this is absorbed in the boric acid solutions, and this is backward-dated with the sulfuric acid, and from that we can calculate the how much nitrogen present in the compost sample. And in case of phosphorus and potassium, you see the nitrogen is a separate thing, but potassium and potassium and phosphorus or micronutrient is not volatile. The nitrogen is volatile as we have to estimate through the ammoniacal form. That is ammoniacal form. That is gaseous. But in case of phosphorus and potassium and micronutrient, we have to estimate or we have to analyze as such. And this is not volatile form, the phosphorus, potassium, and micronutrient. And for that, we have to digest the samples, and by taking the 1 gram of soils, 1 gram of the samples in a evaporation dish, and add 5 ml of 9% magnesium nitrate and evaporate to dryness. Then we remove the organic matter through ignition in the furnace, and then the whatever is left, left residue is dissolved in the 10 ml sulfur hydrochloric acid, and this hydrochloric after dissolving in the hydrochloric acid, we prepare a stock solutions of 250 ml solutions, from where we can detect or we can estimate the phosphorus, potassium, and micronutrient. In case of phosphorus, the procedure is slightly different because we have to develop color, and we go for the phosphomolybdate formations, and this phosphomolybdate is dissolved in the standard concentration of the standard alkali solutions. This alkali solution is backtitrated for the estimations of the total phosphorus in the compost, and this is at first we precipitate with the ammonium molybdate solutions. Then this precipitate ammonium molybdate is dissolved in the sodium hydroxide, and this excess sodium hydroxide is backtitrated with the sulfuric acid, and this from that blank samples, for compressing the blank samples and the titrated samples, we can estimate how much total phosphorus is present in the compost. And in case of potassium and in case of micronutrient, we can take the samples from the whatever the digestive soil samples we have prepared, and directly we can estimate through flame photometer for potassium, and the through different types of micronutrients through AAS. And this is the method for the different for the estimations of the phosphorus, and this is the procedure how we calculate, how we estimate the different types of nutrient present in the compost. And if we see as a whole what is the need of this analysis, why we are so much giving importance for the analysis of the compost, then we can say that widespread nutrient deficiency and deteriorations of soil health are caused to low nutrient use efficiency, productivity, and profitability. Because at present our soil is become gradually low productive, and the farmers are not getting higher income from the soils after applications of the huge amounts of chemical fertilizer in the chemical organic agriculture system. And because the soil health already deteriorated due to the continuous applications of the chemical fertilizer without applications of any organic source. So the production system become deteriorated, and that is reflected in the form of reduced yield from the production systems. Then adoption of site-specific balance and integrated nutrient management involving major, secondary, and micronutrient, organic manure, biofertilizer, and amendment. In this case, we are whenever we are applying or when we are recommending a fertilizer dose, we should consider all different types of nutrient available present in the soils, and we should calculate accordingly whatever nutrient present in the organic manure. And effective soil testing service to back up the precise fertilizer use, that is manure use, that effective soil testing service, because before recommendations of any fertilizer, effective soil testing report should be there, and from that report we can calculate how much organic source of nutrient we have to apply for a particular cropping crop in a cropping systems under organic production system. Then creating awareness among the farmers on the benefit of balanced fertilization and region specific fertilizer recommendations for different crops, because whatever we are applying in the Modipuram or in the UP, the recommended dose is different from the Tamil Nadu, Karnataka, Kerala, and it is different from the Gujarat to Manipur. So the region specific recommendations should be there, through which we can recommend the farmers the different source of nutrients for fulfill the requirement of the crops. And this is the last, because in overall I have tried to cover all these sections, because at first I start with the nutrient source of nutrients, how we calculate and how to recommend, and on the basis of the fertilizer. And I think this discussions or this lecture will be helpful for all you all, and I am very much thankful to the organizer for giving me the opportunity to discuss our views, my views in this respect. Thank you.
Thank you, sir. The session is open for discussion. Any participants is any having doubt, they can discuss here.
Before start, I told that the section should be interactive. So we should ask.
Any participants? Hello.
Because this will helpful for during the preparation of synopsis. Because you have to give, we will give a assignment for model 3, model 2.
Okay, I hope there is no questions from participants.